Hi everyone and welcome back to my YouTube channel. In this video, you're going to creating here a game controller that you see in the screen. We're going to controlling this game just using here the post estimator using MediaPipe library. So I'm not expert of playing this kind of game, but you can. So without any further ado, let us start our tutorial right now. So first, let's have a look the game control logic, and after that, you're going to see the code. So this is the game control logic. So I can just click on here and click on Markdown, Preview, and Hinge. And then you can see it correctly. I mean, we see it cool way. So not started, wait for hands join gesture. That's mean when we join the two hand, then our program will start tracking and we can jump, we can uh, go to the left, right, or we can also crouch. So started, read, poster, and the positions to the simulate. Okay, posture and the position to the simulate. It will first checking the shoulder positions, and then we are going to using here a library for automate the thing that's called the pi otugoi. So pi otugoi press left and right. I mean, we can go to the left side or you can also go to the right side. Then for the jump, you can using the press the key from the keyboard that's called up, but you're not going to using here the keyboard. You're going to using here the pi otugoi. So there's a pi otugoi press up, and for the crouch, you're going to using here pi otugoi press dot down. And start game or jump again pi otugoi click or pi otugoi press or space. I mean, if I want to start here the game again or jump again, I can using here pi otugoi click. So this is the game control logic. Simple things. First one is wait for the hand join. I mean, when the hand is joined, then you start our game. I mean, you can start tracking or you can start controlling our game. Now, let's have a look at our code first because this is the important one. So I'm not going to do the live coding here. I'm just going to explaining here all of the code line by line. So this is the code main.py file, and I'm simply going to closing this out. It's not needed at all. I can save it, and I can also closing here this preview logic.md file. So first we're going to importing here some of the important library like CB2. It's nothing but for image or video processing. Then the Pi or Togo library that you see before. So using this library, you can automate here the keyboard, mouse input used to simulate the game controls basically. Then from times, you import here the times. It's actually using the times interval for the FPS, I mean the frame per second. The frame per second that you can see in the demo, it's quite low just because of my recording is also on, as well as my program is also running. So that's why the FPS is quite low. We also see that how I can actually calculate them. Then from math, you're going to import here this HYPOT. So which one is nothing but for calculating the distance between point for the hand joining. So when you start the game, you need to also join the hand. So this one is nothing but for calculating the distance between the left hand and the right hands. They also import here the MediaPipe, which one is important library for detecting the hand gesture or detecting the pose of the persons. Okay, so it's nothing but a fun project. I just do it. And then you import here the matplotlib but pyplot.plt in order to show or display some kind of images for the pose or hand gesture or anything else. So because you're not going to using here the hand gesture here, we are going to using here the pose. So what it actually, so if I see in the PowerPoint presentations, so it's nothing but look like that, the pose of the human full body. So you can see nose, the left eye inner, left eye outers, everything you can see that. So you're just going to actually detecting here the key points, and based on this key point, you're going to jump, you can crouch, or you can go to the left, or you can go to the right. Okay. So let's go on here. So what I can do is simply going to creating here a variable for pose. That's called mp pose, mp.solution.pose. And after that, we're creating here two variables. One is nothing but for the pose images, another one is for the pose video. So we're actually using here the video one. We are not going to using the image one, but if you want to display it, yes, you can also display it in terms of matplotlib. So that's why. So see pose dot and pose underscore images is equal to mp pose dot pose, and you give it here a static image mode is nothing but the true because image is nothing but all kind of static things, and minimum detection confidence 0.5. So if the confidence is up to 0.5, we're simply going to detect it out. And you have the model complexity, you just give it here 1. Okay. Same thing for the video. You can see mp pose, and you have the static image mode is nothing but false because it's not taking the static mode images. It's just going to go to the video mode. Then the model complexity 1 and minimum detection confidence is 0.7 in case of video because it's needed. And mean tracking confidence are 0.7. is nothing but for tracking the person, because the pose is only available in the case of person, right? That's why. Then you're also creating here a variable for MP drawing, so that you can also drawing this out. If I see that the pose is nothing but detecting here the key point that you can see 4, 5, 6. That's like key point, and you can see some kind of drawing. It's nothing but the joining. So for the joining, you're actually using here this MP drawing. So MP drawing is equal to mp.solution.drawing utils to drawing that. Okay. So in here, into creating here three of the methods: detect pose, check the hands joint, and check left or right hand. Then we also have the check jump across. Sorry for that. Actually, we need to creating here the four functions, and as well as we need to also creating here on main functions. I mean the main part. This is the main part. So this is a simple code. I'm just going to explain it here. Okay. First, let's have a look. The detect the pose. Okay. So how can you take the pose of using here the MediaPipe library? So first, you're going to creating here a functions called detect pose, and which are taking the image and the pose in the parameter, as well as draw is equal to false and display is equal to false. Just give it to here. Okay. And then you're going to taking one copy of that in here. So you're creating here copy. So image.copy, and I just taking it out so that the original image is not going to gone, and then we convert it into the RGB. Why? Because you know that OpenCV read the images in the BGR format, so you need to also convert them into the RGB. So that's why I actually convert it. And after that, you're going to using here this post dot process. So the post is actually created. We actually created, or sorry, we created, and it's also passing this out inside the parameters. So you're going to using here post or process, and you're processing here this image RGB that is coming from here. So if the result dot post landmark and draw, I mean if the result have the landmark, if the person is available in front of the camera, it will drawing the landmark. Okay, and also if the draw is equal to true, then you're simply going to draw it. So you're going to using here this MP draw utils. So MP drawing dot draw landmarks, and you're passing here the image, and image is nothing but our output image that we actually taking out from here. And this image, it can be a static image or it can be the video, but in our case it's a video. Then you give it here the landmark list. So landmark list, you can get it from results dot post landmarks, and connection is nothing but mp post dot post connections. So post connection is nothing but this one, this connection to this connection, this connection to this connections, and draw utils is nothing but drawing it out. Okay. So then you have the landmark drawing specifications. So using here mp drawing down drawing spaces, and we give it here some kind of color codes. So 255 255 255 is nothing but the white colors. Okay. So thickness 3 and circle radius is 3. I mean the circle that you can see, the circle you can see. And also connection drawing spaces, and we give it here some kind of color, somewhat color in case of drawing the connections, I mean those lines. Okay. So this is nothing but for the drawings, I mean detecting the pose only. If you want to display it, you can also display it using the plt.figure, I mean the matplotlib, in case of static images. So subplots 1 to 1 and plt I may show. I just give it to here. Okay, original image. It's not needed. You can also removing this out. Uh, if you want to display it out, you can obviously display it out. Otherwise, you're simply going to returning here the output images. I mean the output images is these ones, and our results. Our result is nothing but these ones. Okay, the result that you have. Now, we're creating here the functions for detecting the pose of the persons. Now, we're creating here another function for checking the hand joints. So this hand join is nothing but for starting here the game. So how you actually join the hand and our game is already automatically start, but our frame is not started for controlling the games. That's why. Okay. So how you actually joining the hand, join the two hand, and then our game controller is start working. Okay. So that you can see the demo, but you're not showing here the starting point. Unfortunately, I forget to record it. Okay. Okay, but let's try to do it later on. So check hand joins, and you can see image results, draw and display. So result is nothing but coming from here, because it's also passing here the result in here. So we are taking here the image dot shape. I mean image is nothing but the video itself. So image dot shape, and taking in copy for the output images. Now how we actually getting that our hand is join each other's. So if I go inside that, you can see here this is the left hand side, and this is the right hand side, like that. Okay. So if the distance of the two is a minimum, that's mean our hand is joined like that, right? So let's see the actually uh, the logic behind it. Okay, so you calculate here the left wrist landmark. So how can you calculate that? So result dot post landmark mp dot post landmark dot left wrist. See, it has the functions dot x. See, dot x is nothing but in the x coordinate, and width. So the width is nothing but the shape of the images or shape of the video. So based on the video frame, I can determine then here is my left part, here is my left hand. Same thing for the height. You can see same thing for the height. That's been in case of them, in case of the left wrist landmark, how can you get them? So we have this one, I mean the x coordinate and the y coordinate. You can considering this one as like where. See, this is the portion. Let's say this is the wrist. So how can you calculate them? So you can calculate it the left wrist portions in the case of x-axis and in the case of y-axis. And you define here the height and the weight. We multiply them. Same thing for the right. So just give it here right wrist and width and the height. Now we have the landmark points. Okay, we have the landmark by the wrist. Now how can you calculate the equivalent distance? So see, I mean, you're going to calculate this distance from here to here. Okay, if the distance is low, that's mean the hand is joined, otherwise it's not. Okay, so we using here this HIPOT, and you give it here a left wrist landmark of 0 and right wrist landmark of 0 and left wrist landmark of the 1 and right wrist landmark of the 1. Okay, this is nothing but for the Euclidean distance of the two data points. Okay, so x1, okay, it's nothing but x1, or you can say x1 minus x2 all scale, or y2 minus y1 whole scale, like this. Okay, so this is the formula that you can also use it here in order to calculate the Euclidean distance. Okay, so if the Euclidean distance is less than 130, if less than 130, it's nothing but a point. You can also play with them. So the hand started is nothing but hand joints. So if it is far from them, if the distance of this, if the two distance of the wrist is bigger than 130, that's mean hand is not joined. If it is less than 130, that's mean it's the join. So now when the hand is joined, you can start controlling our game. So if you are given here any kind of draw, I mean if you want to draw it out, so you can also drawing it out. Okay, you can also you can see you can also drawing this out. So it have the distance, how many distance it have. If you give it to here, you can also calculate them how many distance it have. Okay, so don't worry about this code. You can get this code and you can play with this code. You can do it everything. I'm just going to spell in the code. Okay, so I don't have any enough time to do everything again and again. Okay, and my camera is not so good at all, my PC webcam. Okay, but just I do it my using mobile phones. Okay, so display, if you want to display it out, you can simply display it out, otherwise we return here the output image and the hand status. Okay, now we define here the two things. One is the detective pose, another one is the hand joins. Now we start our game. Now the question is the check the left part and the right part. Okay, how can you actually checking here there's uh, if I need to go to the left or I need to go to the right. This is the quite important and quite toughest task. So just go on the PowerPoint presentations. I mean for actually explanations. So I'm just going to go inside this insert. I'm going to go into the shape, and I'm taking here one line. So I'm just going to draw here a line. So let's say I'm going to draw here one line. Line, it should be like that. I need to also okay, the shape should be okay. Let's start drawing this out first. Okay, so here is the line you can see, and then I can draw here. Okay, rectangle should be good, I hope so. Yeah, rectangle should be good. So let's take a rectangle, then you can see it correctly. Okay, so I'm just going to draw here a rectangle. Okay, in here, and also I'm going to draw here another rectangle. So let's say okay, like that. Okay, like that I'm going to draw here a rectangle. Okay, that's it. So I can also make it smaller, and also this one I can also make it smaller. See, what are the logic behind this game? See, so this is the left part, right? This is the right part, right? So, and this is the standard part, or this is center part of the body. So here I need to go to the left part, just mean this data point, this all of the points should be go to inside this portion. I mean 11 should be go to this portion. That means this is the left portions. So if the 12 is go to the this portion directly go to this portion, this means right portion. I need to go to the right in terms of games. And this is shoulder. If the shoulder is up, that's mean I need to jump. And if the point is down, that's mean down. I have to go to the crouch. This is the game logic. See, that's mean the shoulder, main shoulder is nothing but our center point. This shoulder point is center point. Okay. I mean, just we're going to go to the straight line of the game. And then this is the 11 and this is the 12. Let's say I need to go in the left side. So what I can do, I need to making this 11 into this part or this portion. Okay, this portion. That's mean it's directly go to the left part. I mean, the cat or the boy is going to the left part of the game. So if it is 12 is going to come in inside this side, that means the cat or the person should be go to the right side. So if the shoulder is go above, that means it jump. And if this shoulder is go down, that means this is the crouch. Okay, this is the logic behind this game. Okay, so let's checking this out right now. So we are creating a variable called check left and right, and you give it here image and results, and also draw and the display. So you have the horizontal positions for the checking the horizontal and the vertical. So height, weight, we're taking here image dot shape and also copy. So you calculate here the left x and right x, nothing but for the shoulder. You can say right shoulder and the left shoulder. So you can see result dot post landmark dot landmark mp post landmark dot right shoulder into x and left shoulder into this width. Okay, now you can see one kind of logic that you can see. So if the right x is less than the width by 2, I mean you divide them into 2. Why? Because you can see divide them into 2. So width by 2. Okay, width by 2. It is the less than, if it is less than as well as the left portion is less than, that's mean this is the left part. I mean this is the left part. Okay, so if it is greater, that means this is the right part. You can see this is the right part. Okay, if the right x and the left x is greater, I mean this portions is nothing but the right part. Okay, so if both of them, if the both of them not both of them actually, if the right x and right x is bigger but left x is lesser, that means this is the center. Okay, if the left x is lesser and right x is the lesser is nothing but the center. I think in these images that you can see. Okay, that's the one mistake actually. So calculating here right x as a left shoulder. Okay, I mean we're flipping this out because in case of images, so that's why I am quite confused. Okay, that's mean this is the right part and this is the left part. I mean you just give it to here. That's mean in the case of left part, the value should be the smaller. Value should be a smaller in kind of cases because it's the kind of flipped. So that's mean this is nothing but the center. You can see the centers. Okay, this is the logic that you can see. If the right part is less than of the width by 2 as well as the left part, that's mean this is the left part that you can see the left part, and otherwise it is the right part, otherwise it should be inside the centers. And then you have the draw and you have the display, and same thing output image and the horizontal positions. Now we need to also checking here the jump and cross. It's just checking here the left portion, the right portion of the center, and now jump and cross. Same thing left y and the right y. And in case of left and right, you have to calculating here one thing that's called the meet. Okay, because you see this is the meet point. So if it is down, and that means the crouch. If it is up, then it's the jumping. Okay, so you calculating here the actual meet y. So you using here abs right y plus left y divided by 2 because you need to divide them the midpoint. Now we got the midpoint. So if the lower bound is nothing but 50, if it is less than 50, I mean minus 50, that means it's the lower bound, and it is 100 above, that means it's a quite big jump. Okay, so if the actual mid y is less than lower bound, it's nothing but jumping, I mean, is the jumping. And if the actual meet is greater, it's nothing but the crossing. And otherwise, the pose is nothing but the static. I mean, this person. Okay, this is the logics. And if draw, you can simply gonna drawing this out. If you're not drawing here the pose. Okay, so I'm not going to discuss about that actually. So then we are going to creating here our video capture object in order to show here video. So video is equal to c video captures of 0 and video set equal to 3 comma 1 to 80 or 960. Okay, you can also make it as a 1 if you want to use here the droid cam. I'll show you later on. And then you're creating here some of the variables for time the game started, the position of the x and the y, meet y, counter, number of frames. So those position is needed at all in case of the detecting here the click. And meet y is nothing but for calculating here the meet value because meet y. Okay, then into passing out here. Okay, then you're going to creating here while video is open methods, and then we checking here video dot read. We have the read and of the frame. So read is nothing but the binary things. If you have any problem, so it give me the 0. If you don't have any problem in the camera, it will give you the yes. So if not read, that's when you can continue, and then you're going to flipping it out. cb2.flip of frame 1. So that's why in case of this left y and right y, you give it here right shoulder inside is left and left shoulder in the case of right. So that's why we actually give it, because we flipping here the frame. That's why. And then you're checking the shape of the frame, and then you're calling here detect pose to detecting here the pose of the persons. So if the result.pose is landmark, I mean if it is actually uh, uh, the okay, and then we're going to draw the pose. Okay, and inside this draw, we give it here the game started. By default, game started is false. So when we game it here, the game started is equal to false. That's mean it just it not detecting the pose. When the game is not started, we don't join the hand. It not detecting here the pose. So if we had joined the hand, if we join the hand, then the pose is detected. So if the pose is detected, that means game is started. So if the game is started, then you're checking here the left portion and the right portions. Okay. So if the horizontal position of the left and x position of the index is not equal to 0, that's mean this is the left portion. We can pressing this out, and or the horizontal position of the center, because it's also available for the center one. In case of that, it's also the center one. If this value is going to the center, that's mean obviously this is the left portions. If this value is going to the this portions, this center, obviously this is nothing but the right portions. Okay. So same thing you can say right. So position is equal to right, and if the pose index is not equal to 2, that's mean we give it to here as a the right portions. Okay, right portions. So and you give it here pi equal to price of the right portions and x pose index plus 1. Okay, and in the case of left portion, you give it here minus 1s. Okay, and then we give it here some kind of things. If the game is not started, so join both hands to start the game. This is nothing but when the game started is false. And then you give it here font equal to cbt.font hash simplex, and scale of the font 0.9, font thickness, the text color, bg colors, and also get text size, how many gets you can get. And you're creating here rectangle and the put text. Okay, I'll show you. So just give it not accelerate at all. And then checking the hand joins. So if the hand is hand joins, so then we can simply going to actually uh, press the space so that you can start here the game. Okay, so when the hand is joined, we press the space and our game is started. Okay, so counter is equal to 1, and if the counter is equal to number of frames, okay, is equal to number of frames, and number of frames is by default 10. So if it is nothing but the 0 after 10 seconds, you're going to starting here the games. So if not game started, and then we gaming here making here the game started is equal to true, and we checking the left y, right y, mid y, so that we can also go to the left portions or the right portions. Okay, in case of the check hand joints. So if the mid y, then we checking for the uh, we checking for the jump and up. So frame is equal to posters. We checking calling here this check jumper jump cross, and we passing here the frame result meet y and draw is equal to true, so that it will drawing this out because our game is started. So if the poster is equal to jumping and y poster is equal to 1, then you're using here pi to guy dot press of the up, and otherwise down for crossing. In standard, we're just not going to press anything else. We're just making y pause is equal to 1. Okay, otherwise counter equal to 0, and we are actually calculating here the times. So this is nothing but the FPS. So if the time 2 minus time 1 is nothing but the if greater equal to 0, then we calculating here the frame per second. So frame per second is equal to 1 divided by time 2 minus time 1, and you give it here the frame per second in the frame of in the case of put text. Okay, this is how you can calculating here the frame per second. Then you show it out cbt.yam show survey surface with pose directions and frame, and cbt.white key, and this is okay. Now how can you enable here the droid cam? I mean, how can you using here your mobile phone camera? So for that you need to change one thing on here. So it should be the one, and also if you're running this on right now, then you can see one thing, it not showing anything else. Okay, it not showing anything else, but when you connecting here the droid cam, then it will show you the camera. Okay, just I need to waiting for a few seconds. Actually, I'll show you in a live. So I hope it started. You can see started, you can see the frame, you cannot see anything else. But when I am going to, okay, how am I am going to actually using here this droid cam. So let's say droid cam client. So droid cam client, so let us start. Now you can see the camera that you can see. Okay, camera, and also you can see in our frame, I hope so. Okay, don't see anything else on here. I can stop it, so I can go to the code. Now if we're running this out, I hope so, need to saving this out. And now if we're running this out, and then you can see it able to access here the camera that you can see. Okay, so you can see it able to access the camera. Okay, that you can see the code, everything. Okay, everything you can see on here. Okay, that means you can see that how can you accessing here the camera using the droid cam. Now I just using here my mobile phone. Okay, so this is how you can actually access here the mobile phone. You can press the ESC from your keyboard. Okay, now let's try to testing it out. The out of the home. Okay, so I hope you enjoy it. So let's testing it out, then I'll back again. So that's it for today now. Hope you enjoyed this full tutorial, and make sure to subscribe to my channels and share with your friends. This is nothing but a fun project. Actually do it. Thank you and bye bye.